Alright, welcome back friends and neighbors. We are going to do a video that's a little bit of a build, and we're going to do this build because we want to solve a particular problem, and that is capturing network traffic between a couple of routers. So without further ado, let's go ahead and start a build. I'm going to get out a couple of routers here, and I'm going to interconnect my routers right here. So we'll do F0/1 to F0/0. Now, to illustrate the problem, we're going to go ahead and add a couple of nodes here as well. And eventually what we'll want to do is capture, sort of what goes on in between the routers. I suppose we can put another switch in here too. And we'll do a 2960. And we'll go ahead and connect all of our machines. And so maybe what I'll do is make this, I don't know, call it PC10, and we'll call this one PC20, and we'll go ahead and make our networks that way too. There we go. So we'll do 192.168.20.1. and the gateway, of course, 192.168. Well, wait a minute. 10.254. What did I do for the? Whoops. Let's do that. There we go. And of course, this will be the 20 side. 20.1. Oops. Forgot where I was configuring things. 192.168.20. Geez, having a little trouble with my brain today. Alright, that should do it. And we'll take PC10 and connect it to port 10. And PC20, we'll connect it to port 20. Alright, we will connect our routers maybe to ports. We'll go. Hey, you know what? Let's actually make a point here, and we will connect to the uplinks, because a lot of times we connect routers to the fastest port that we have on a switch because they're uplinks. Now it doesn't actually do us much good here because these routers are fast Ethernet port routers, but there we go. We've made the point. We've made the point. Alright, do a little bit of labeling. We know that this is 192.168.10 net, and we did /24. And over here we have 192.168 20.0/24. Now I'm also going to do this. Let's create a VLAN so that we can further illustrate what we want to do here. So if I said something like I'm going to put this PC in a VLAN along with the router. So I might say something like this. We're going to do an interface range command. And we know that that's connected to port 10 because I was futzing around that way. And I did put the gig 01 into the same VLAN. So I'm going to put them in the same VLAN. So I guess I don't need the range command. But we'll do switchboard access VLAN 10, like that. And we'll also we'll just do the interface. And we'll do switchboard access VLAN 10. And we'll make sure that I did this right. There we go. So these two are in VLAN 10. Now let's configure our router. No thank you. And we'll go to int F0/0. And we'll say IP address. And we want this to be the default gateway for our host. And we'll do a no shut. There we go. So now theoretically, as soon as this comes up, we ought to be able to talk to the node. But while we're waiting for that, let's do our other VLAN and configuration here. So int F0/20 switch port access VLAN 20. And then we also need to do that with, I believe it was G0/1. There we go. And we will bring this guy up. Okay. This should be F0/1 if I'm sticking to my convention. And this will be on the 20 net. Whoa, that's not going to work. Do a no shut. Now theoretically I ought to be able to ping the host on this side. Like that. Nope, the port is still coming up, so maybe we'll do this side. And we get a lot of times we'll get that first delay, as you know now, because of we're waiting for ARP to resolve itself. So there we go. All right, and we'll try again over here. And there we go. All right, and just to show you, just a reminder, right? We got our VLANs here. All right, so we have a switch and it's got VLAN 20, but we also have to remember that it's got VLAN 1. And over here, we have VLAN 10, but we also know that anybody that's not in VLAN 10 is in VLAN 1. All right. Well, what should we do with the middle? And I am gonna, we'll just go off the reservation here. We'll make this 172, I don't know, 19.0.0/16. So we'll make this a class B, and we will go ahead and set up our router interfaces. So int f0/1. And we'll make this 172.19. Is that what I picked? Yep, 0.0.253 maybe. 255.255.00. No shut. There we go. Now we got to do this other side. Make sure that I remember what I picked. It's 53. This should be 0/0. 172.19.0.254. There we go. No shut. Now, before we can really get to our problem, we do have to establish connectivity here. So we've got this router. If we take a look at where we are, right? So we'll do one more thing here so we know. Hostname R2. And if we do a show IP route, this router knows about the 20 and the 172.19, but he doesn't know about the other ones. So we've got to add a static route here to 192.168.10.0. We'll put in the mask. We'll put in the correct mask. Now, who's going to be our forwarding router? Well, let's remember that this is 253 here, and this is 254. So I'm going to say 172.19.0.253. And that should do it. So this router is going to point over here. We have to do the same thing over here, or at least a similar thing. So I'm going to do an IP route, but this time we're trying to get to the 20 net, right? 255, 255, 255. And even though we've done this lots and lots of times, it's good to do a little bit of practice. So this will be going the other way. So we need 254. Well, what is the impact of that? Show IP route. We've got our two directly connected networks here, right? There's the top network. There's our 10 net, and now we have a static route. Now, if we do our ping, we go for broke and we go all the way across. We expect this to time out initially because there's going to be an ARP exchange here, but we should eventually be okay. As long as I did my static routing all right and connected everybody the way they are. Hey, look at that. All right, so we have success, so we know that this topology works. But if it wasn't for Packet Tracer and our ability to do a simulation here, I couldn't, in the real world, I couldn't see the traffic here. So we're going to modify this behavior, and I'm going to do it on this switch right here. So let's get rid of this particular link right here. And so what I'm going to do is run this link down to the switch, set up a monitor, and then I'm going to run it over there. So we're going to get rid of this link. And I want to keep the networks the same, so I'm not going to change the configuration. I do have to remember where my VLANs were. So that was port 10 and G0/1. So I'm going to go ahead and do F0/1 and 2 here, just to make my life a little bit easier. And there we go. So we'll put a note here, right? This is going to F0/1. And over here we have F0/2. Now another question is, who will my monitor be? Well, since I have this node is going to generate the traffic, I'm going to go ahead and stick another node in here, right there, and we will connect this node to port 3. Like that. So F0/3. Now, we said that we want to watch what's going on in between these two routers. Okay? Now, this won't be an actual packet capture, but what we are going to see is that the simulation sends traffic over here. And we'll cover that, when we get to that point. So what's going to happen is that I'm going to ping from PC10 to PC20 again. I'm going to do the exact same thing, and we'll just verify that that still works. Now remember that when we took the interfaces down, right, the ARP tables were cleared. So this still works, but we have to remember that all of these right here are in VLAN 1. So maybe what we'll do is we'll say, this is VLAN 1 here, VLAN 1 here, and VLAN 1. That was weird. Okay. So all of these connections are in VLAN 1. This is VLAN 10 over here, right? So what I want to do on this switch is I want to copy the traffic from either this link or this link. It doesn't really matter which one because they're the same. They're doing the same thing, right? It's the connection between the two. So I'm going to go ahead and source F0/. Let's see, what do we do here? So this is referencing this guy here. Go away. Well, we got this link right here, this link right here, and this link right here. Whoops. There we go. That label finally went away. So we're going to source F0/1 maybe. So what I'm going to say is monitor session 1 source. And again, it could be F0/1 or F0/2 in this case. But I'm going to say source interface F0/1. And then I'm going to say, well, where do I want this to go? I want it to go to PC2. So that would be F0/3. Now, the let's actually do one more thing. I'm going to remove that command. I'm going to say I'm going to get rid of this guy here because we want to see how it works normally. Okay, so I'm going to pull up the simulation, and what we should see is that traffic going from PC10 to PC20 goes up to the router, its default gateway, down to the switch, over to this router, and then back over here. It should not come to PC2. and then we'll instantiate the monitor session, and then it should. So here we go. We're going to go ahead and do the ping again, and we're going to let it play through. So up to the switch in VLAN 10, up to the router also in VLAN 10, down to the switch in VLAN 1, over to router number 2, still in VLAN 1, down to the other switch in VLAN 20, and then finally down to the PC. And the response is going to work the exact same way. Okay, so it's not going to our monitor node. All right, so we'll go back to real time here. Let that finish. There we go. All right, so now what I'm going to do is I'm going to put that monitor right back in there. So now we're going to F0/3. And what should happen is that we should be copying traffic that comes down to port 1, and it should also go over here to PC2. So let's see what happens. So up to the switch, up to the router, down to the switch. It's going to go over to router 2, but it also goes to PC2. That's because we have that monitor session involved. So now PC2 is seeing anything that happens between router number 1 and router number 2. So here comes the return trip. By default, monitor sessions listen for both directions of traffic. There we go. So, what's the point of all this? In the real world, we can't stick a hub out there sometimes. Now, a lot of times on routers, we'll do another protocol like NetFlow or something like that, or we'll use the statistics to figure out what's going on. But if we really want to see the packet traffic, the monitor session, mirrored ports, synonym, right? Span ports, these things are all ways that we, in a modern communication architecture, capture traffic to see what's actually happening across the network between two point-to-point links. Well, there we go. Hopefully this helps. We did a quick review of, a small static routing problem, and then we solved the problem of how I would capture between two routers on a point-to-point link. May those packets always reach their destinations, including monitor stations. And hey, it's networking. You can do this.